office. Welcome, Kelly. It's great to have you here.
Thank you, Daryl. It's fabulous to be here helping to cheer DART off the planet.
Now, right at the top, let's talk about this. Are there any asteroids threatening Earth that we know of?
Now, thankfully, there are no known asteroid impact threats to Earth. We keep tracking them. We don't know of any. It's the one that we don't know about, that we're concerned about, but that's why NASA surveys for near...
Okay, and this asteroid DART is going to hit. What's the story there?
Well, the asteroid Didymos does not pose an impact threat to Earth. It keeps its distance, it gets no closer than 3.7 million miles to Earth's orbit. But that's what makes it a fabulous test situation for DART. We can go safely test an impact, the kinetic impact technique, and Didymos is the perfect laboratory for that.
Okay, and this spacecraft, is this something that could one day save the planet?
Well, what's nice about this, it's a nice mature technique, kinetic impact. You just impact something, but now we're actually going to test it. So this is going to be really good to have something in the toolbox that we've actually tried, taking it from modeling to an actual test.
Well, it is certainly exciting just to hear you talk about it, and when that moment happens in the fall of 2022, with a quick breakdown of the DART spacecraft. DART has a mass of 670 kilograms, about a golf cart size or vending machine size machine. It uses hydrazine thrusters for propulsion and roll-out solar arrays for electric power. Now, DART has just one instrument on board, and there it is at the bottom, and that instrument is a DRACO camera, which will feed images to an autonomous navigation system steering it smack dab into an asteroid. Now, here's how DART got here. It was pulled by this semi-truck 2,900 miles across the country from the Applied Physics Lab in Maryland, all the way here to the Vandenberg Space Force Base. It took the team 46 hours to make the trip. You see that box right there? That's the protective container that was removed and is being stored here in the NASA hangar, while this DART spacecraft was carefully prepared for the launch and then put into that protective fairing. What a beautiful shot that is, Kelly. And then earlier this month, engineers made the DART spacecraft inside its protective fairing to this SpaceX Falcon 9 rocket, which you see here. And DART's at the top of the rocket. It was then rolled out to the launch pad at Space Launch Complex 4 East, where it is now awaiting liftoff at 10:21 p.m. Pacific, 1:21 a.m. Eastern Time. Now, as we follow pre-launch operations, we also have some cool stuff to show you along the way. Our own Kelly Fast will give a fun demonstration. There she is. She's going to help us visualize a close approach asteroid. And she's moving quick. We'll also head into space where two astronauts will demonstrate in microgravity the kinetic impact technique that DART will be using. And also, this is kind of fun. We'll hear from a Hollywood director, Adam McKay, about his new science fiction comedy, Don't Look Up. It's about an Earth-ending comet that he'll compare with reality. Step on launch operations and introduce our launch commentators for today, NASA's Marie Lewis and Denton Gibson. Marie, preparations have been going on for many hours. Where do we stand right now?
Well, at the moment, Daryl, everything is still go for launch. We listened to polls just a few minutes ago internally with the spacecraft team and NASA engineering. No red flags, everything looking right on course. Want to introduce our commentator who's making his debut launch commentary tonight, Denton Gibson with the Launch Services Program. You're a mission manager, no stranger certainly to Falcon 9 and missions like this, but this is your first time in the commentary booth, so welcome.
Oh, thank you for having me. I'm excited to be here. It's launch day, so I'm looking forward to this.
And the teams on console have been going through their steps methodically since a little before 7 o'clock this evening Pacific time. There is a live view of the face, and in less than a minute we expect to hear the NASA launch manager Omar Baez poll the NASA team for launch readiness and readiness for propellant load to go ahead and proceed with that. If that is all go, that will begin at T-minus 35 minutes.
Right. And the reason why you hear this poll at this point in time, because there's so much going on much later in the process. So they try to have the poll early so that way the team can focus on the telemetry and focus on the data coming from the rocket and really pay attention to everything that's going on leading into those last few minutes.
We're just standing by for that NASA launch manager poll.
Our propellant Loading pole, starting with SCE.
SCEs go.
SMA.
SMA is go.
SMD.
SMD is go.
NASA Mission Manager.
NASA man is go.
LSP.
LSD is go.
Team driven students of okay.
NASA teams to make sure that they're ready to go proceed with propellant loading and launch. That's the various teams that you heard the NASA launch manager pull in to make sure that they're ready to proceed with the count.
One thing I want to point out as we look at the rocket live on the pad on an unusually clear night here at Vandenberg is the soot on the side of the rocket, and that is because this booster has already been flown twice, in fact, but this is the first time for a launch services program mission.
That's correct. We've done a lot of work getting to this point. We're comfortable where we are with this, and we're looking forward to this launch. And we have a lot of familiarity with this booster because we actually launched this for the first time on Sentinel-6 almost a year ago today.
Yeah, so interplanetary mission. So really exciting stuff coming up. By the way, weather is 90 back to you.
All right, thank you, Marie and Denton. And so that's a great report. They're fueling up the rocket. Kelly, it's getting kind of exciting.
I'm really relieved to hear that report that that looks like things are going to go. And I think of the DART team. I mean, they've been working on this for years, but they brought a spacecraft to the launch pad through a pandemic, and so they really need to be commended.
That's a great point, and you are right about that. Astronomers now all over the world. What's interesting to me about this is after this impact happens, they'll be able to see some kind of change.
Right, it's a unique mission in that there's an astronomical component to it. When DART impacts the moon of Dimorphos in fall of 2022, it will change the orbital period of that little moonlet. But from the Earth, it's just a point of light, but that point of light varies in brightness because that moonlet travels in front of and behind Didymos, and so that can be measured, and that rate of that light going up and down is what they're going to measure, the change in that, and that's how we're going to see exactly what DART did to Dimorphos.
That's fascinating to me because it's literally just light you're looking at. We've never seen this little moonlet, but we see the light, and that's how we gauge it. More stuff to come from Kelly. Thank you very much. We are T-minus 41 minutes and counting. Here now is everything you need to know about the DART mission.
DART stands for the Double Asteroid Redirection Test, and the DART mission is to basically go hit an asteroid and see if we can move it. Earth is surrounded by small objects called near-Earth asteroids, and some of them are potentially hazardous. So planetary defense is cataloging, figuring out what all these objects are, but also trying to prevent them from hitting the Earth.
So far, we've only been able to predict the impact of 2 or 3 objects ahead of time. Those objects were small enough they burned up in the atmosphere and they were no danger to anyone. But what happens when an asteroid or any object is going to impact the Earth is that the Earth and that object want to be in the same place at the same time. We can't change the speed of the Earth, so the idea would be to change the speed of the impactor.
Now we chose to do this demonstration at a binary asteroid. The main asteroid is called Didymos, and its moon. DART is actually targeted to the moon of the Didymos system. And that's a much smaller target than any spacecraft has ever managed to hit before.
This is the first mission to fly the next sea. There's the ROSA, the solar arrays, have an Italian CubeSat, but it's really all about smart navigation.
The DART starts out with a traditional mission design concept where we use star trackers and optical navigation. This will be the first time that the spacecraft will autonomously guide to a target.
The narrow-angle camera will be used by the spacecraft to home in on the target and hit it. And then the CubeSat will fly past the target and it will return the data directly to Earth on its own.
The tough part about it is that we're guiding ourselves into the asteroid, we're taking pictures, and we're sending data back all at the same time. You know, Didymos is a system that is tightly locked together, so we're going to try to push on the little moon and try to push it away in such a way that it will change the orbit of the asteroid and it will move it.
Mostly what we're looking to do is change the speed of the incoming object by maybe a centimeter per second. That's not very fast, but if you do it enough seconds in advance, you can cause it to miss the Earth entirely.
DART is actually the first planetary defense mission. This is a continuing series of missions for planetary defense. we had this unique opportunity to demonstrate the method and also to learn exactly what happens when you crash a spacecraft at high speed into an asteroid.
While the launch and spacecraft team are busy preparing for liftoff, the mission operations team, located across the country in Laurel, Maryland, is preparing to communicate with the DART spacecraft after an hour-long flight on a Falcon 9. Let's bring in Samson and Rainey now to find out what they're working on.
Hi, Daryl. I'm at the Johns Hopkins Applied Physics Laboratory, which has a number of historic milestones in space. We're talking about the first mission to orbit Mercury, the first flyby of Pluto, and of course here we are with our next major milestone with DART. Right now I'm standing outside of Missions Operations Control, which is essentially the nerve center for the spacecraft after launch. It controls everything from propulsion to the power supply. So let me give you a quick lay of the land here. If you look behind me in this corner, there's a U-shaped configuration. That's called the command pit, and it houses the flight controllers as well as the mission operations manager. Now, flanking the command pit on either side are the consoles for the subsystem experts. Right now, the team is basically looking at their consoles and making sure all systems are green or a go for launch. Now, it might seem like quite an uneventful scene in the back as you're seeing right now, but I spoke to Ray Harvey earlier. He's the mission operations manager, basically in charge of the overall health and functioning of the spacecraft. And he said that uneventful, or dare I say boring, is exactly what we're going for in this final countdown to launch. So there's a lot going on here, and what's going to happen is, what's cool about the spacecraft after launch is that there are a number of pre-programmed and automated sequences that will occur. So about an hour after launch, these spacecraft will separate from the launch vehicle. At this time, the spacecraft will be in a rapid rotation. So at that point, thrusters will engage and fire and bring that spacecraft into stabilization. They call that detumbling the spacecraft. Now, after the spacecraft is stabilized, the next part of the automated process happens, which is the unfurling of the ROSA solar arrays. Now remember, each array is 28 feet long, so it's going to be an intricate multi-step process to bring DART's wings to spread. And so that probably will take 2 hours alone for that process to happen. So after the spacecraft goes through those automated sequences successfully, the team will then take control of the spacecraft. Navigation systems will be engaged, and the team will then bring the DART spacecraft to a default orientation, which includes, most critically, making sure that those solar arrays are pointed toward the sun and gathering energy for the journey. So as you can see, a lot is going to happen tonight, and so the team expects a graveyard shift. But stay tuned, because later on in the show, we're going to come back and talk to some of the engineers and scientists and learn more about the mission. So stay tuned. Thanks, Daryl.
All right, time to turn our attention to a critical component in the pre-launch operation, and that's the weather. It was a beautiful day today on the central coast of California, and fortunately, we also have a beautiful launch weather forecast. So let's take a look at the satellite, and you can see the clear areas we shift from day into night. That's California in the center, of course, and that peninsula there, that's where we're launching the rocket. There are clouds to the north and to the west, but the area around the central part of the state where we are fairly clear with only some high cirrus clouds from a weak cold front that did move into the area and lower the temperatures here. Now, the Space Launch Delta 30 Launch Weather Officer Max Rush says that this will bring